Okay, welcome back to this channel, and today we're talking about float and double. Wanna see what's the difference between float and double? Okay, I think you must find out that there's float data type and then there's double data type. But whenever you try cross-checking, you found out that both contain floating points or precision points. So we're gonna make this clear. How comes we have double and float yet all contain decimal points? Now, assume we have an expression like 1 over 3 that gives us 0.3333 something like that. Okay, so if we have, let's say, float x, float x equals that 1 out of 3, we yield this. Okay, secondly, if we have something like double x equals 1 of 3, and we get the same answer. Okay, copy this and just comment this. So if we have float x with this and double x as this, the biggest difference is that in most cases float takes in decimal points less than 6, and then double has decimal points equal or greater than 6. This is the only difference, the major difference we have. So if we come here in our dev C++ and we need to get rid of all of this, we declare some value, maybe float x for now, and then double x. Okay, let's say double y like this, and we can say size of float, then copy this and paste it on the new line. We call it size of double like this, and here we're printing size of y because our double is y, and then our float is x. We print size of x like this. We need something like a new line to break this to be printed on the next line. Okay, so one, size of float is 4 bytes or about 32 bits. Okay, and then size of double is 8, meaning double can hold about 64 bits. So if you know very well the difference between 32 bits operating system and 64 bits operating system, then float automatically fits within 32-bit system and it traces the whole of it. That's about 4 bytes size. Okay, this is not the right spelling of bytes like this. So 32 bytes is equivalent to 32, 4 bytes is equivalent to 32 bits, and then 8 bytes is equivalent to 64 bits. Okay, so size of float first and foremost is 4, and then the size is 8, right? After, I need us to do something here. We need to check, I told you that this takes maximum of 6 decimal points, and then this can take more than 6 decimal points. So here it can be greater or equal to 6. There's a comment. Oh, it has to be here. There's a comment here, and then this has to be less than 6 decimal points. Okay, we're gonna declare some number. Maybe we say it is x equals to 1.123456789, and then we have y also equals to 1 point, I'm gonna paste the same thing, 123456789 like this. We have the same value, just changing this to be x and this to be y. After displaying the size, I only need to display the final results. So we print x with this works on screen, and we can display this here. Why? Like this. So we don't need the end line here because we don't expect anything at the end. So we can also make this look nice by saying that this float and like this. Then we can as well so we also want to make this look so fantastic by saying this double type, and we display this. Okay, now I want you to watch out this major change. The size of float is 4, the size of double is 8. Oh, I didn't include a new line here. I need this to be printed on a new line before we can do anything. Okay, the size of float is 4, size of double is 8. Then here we have the same result, 1.123456, 46, and here as well it is 46. Now if I want to include the decimal points, we have a library that we have to call in a C++, and that library is called IO manipulator, input output manipulator or manipulation, whatever you call it. And then in this, what we have to include here for it to work is something like set precision, like this. And what does this set precision do? It gives the number of decimal points you want to be. So in this case I want to round off to 7 decimal points. Since we said float takes less than 6, I'm gonna say approximately less or equal 6 and then greater or equal 6. Okay, and copy this, paste it in the next line, and you'll see what the difference now. So here float size is 4, double is 8. Then here we have 1 2 3 4 5 7, and let's increase more precision points. Let's make it like 9. Let's make it 9. Okay, now this is what you get. For float it is 1 2 3 4 5 6. Let's compare with the what we have here. It is 1 2 3 4 5 6 7 8 9, but here we're having 1 2 3 4 5 6 8 4. So 7 is automatically skipped, meaning they had to round off 7 to 8. And then the next place we have 4 from lower. Where does it 4 come in from here? So we had to round off this one to 8. Okay, then after rounding off we have an extra value here which is 4. So you can easily see that after 1 2 3 4 5 6 7 decimal points, we are having an extra decimal point or an extra value that is not in this range. So that's why I'm meaning this can actually take up to 7. Then in the next double we can easily see that we have everything returned the way it is supposed to be, except that now since we gave a precision size of 9, then the moment it comes out of range we have to round off from here. Okay, so it is 1 2 3 4 5 6 7. Then this 8 becomes 9. Why? We want only 9 decimal points as the maximum. 1 2 3 4 5 6 7 8 9. So since this is the maximum and we must have less than 9, then we automatically round off this to 9. So you can easily see that float takes 7 or less, then double can go up to maximum of 15 to 16 decimal points. So that's the major difference between float and double. If you know you have any value that ranges between